In example 2, we're going to graph the equations given in slope-intercept form. Previously, in the last example video, we graphed using a table, and that always works for any equation you're given, as long as you can see the shape of the thing. But really, a much nicer way to graph equations in slope-intercept form, and these are for lines only, when they're y equals, then you can utilize the slope and the y-intercept, and it actually goes a little bit faster. So the y-intercept here is going to be this piece right here. It's the one that's not connected to the x. We call this number a constant, and in this case, when we have slope-intercept form, that 6 is going to be the y-intercept. Of course, when x is 0, 2 times 0 is 0, leaving us with 6. And so we know that 0, 6 is a point on the graph. We need that actually first to be able to graph this, just because if we didn't have a point, we wouldn't be able to apply the slope. So let's talk about the slope. The slope is the coefficient of x. It has to be y equals, and then that coefficient, in this case it's 2, is going to be the slope. Now the slope could be positive 2 over positive 1, or negative 2 over negative 1. We wouldn't write this as a final answer here. The slope is just 2. That's the simplest form of it. But this is going to help us to graph. So it's rise over run. If we went up 2, right 1, we'd be off the graph. So let's stay away from that. Let's use the other form of 2. Negative 2 or down 2, and then right 1. That would work. Down to left 1. This would be down and that would be left. This one you shouldn't plot, so I hope you didn't make that mistake. Unfortunately, I can't erase this Sharpie. But if you're using pencil, which you should for math, you can just erase that mark. The reason why I put an X through that right away is because I noticed that my line here has a negative slope, but my slope is positive. So it needs to go from left to right, it needs to climb or go up. And I figured out real quick that I made that student error of going down to right 1 when we should have gone down to left 1. So even experienced linear equation graphers such as myself can get into that bad habit, and I always check to make sure that my slope is going the right way, and you can alleviate some problems if you can do that. So look, we're just going to draw ourselves a nice line here, and we'll use our straight edge, try to draw this as precisely as we can. So the next one here, y is equal to negative 4/5 x minus 2, is an interesting one. For this one, the y-intercept is going to still be this part right here, the negative 2, but we've got a little bit crazier slope going on. The slope is negative 4/5, which if you write that, when we use it, it's going to be either negative 4 over positive 5 or positive 4 over negative 5. After all, a negative divided by a positive or a positive divided by a negative will be a negative. And we're expecting this slope to look something like this, to go downhill from left to right. That would be a negative slope. Let's plot our y-intercept here, 0, negative 2, and we're going to apply our slope. So our slope here is rise over run. This piece would indicate down 4, and then this piece is right 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And I know I've got the right direction because I'm going downhill as I go left to right. Let's use this other form of negative 4/5. Let's use up 4, and then 1, 2, 3, 4, 5, left 5 here. And you can see that our points are lining up in a straight line. That is absolutely wonderful for us. So we'll draw that straight line right there. And there you have it. 2 equations graphed pretty efficiently using slope-intercept form.